here is a patient who's been ventilated for sepsis and septic shock. He's on high anatropic support. Now we are seeing the CareScape R860 showing us the pressure time scalar, the flow time scalar, and the volume time scalar, and the ETCO2. So we can see very clearly that the patient is on PRVC mode, that is pressure regulated volume control, with a FI of 40, tidal volume of 400, respiratory of 18, I ratio of 1:2, PEEP of 6, and P minimum of 2. We've actually found the FRC. The FRC over here is somewhere around 1657. That's the FRC. That's pretty good for this particular patient. But then what comes to our mind is, what is this happening over here? What is this small dip that is happening over here? Now, interesting to note that if you were to get off this dip, it is very difficult because of the fact that this probably is something called as a flow artifact. Now, what is a flow artifact in PRVC mode? It is probably mode specific. It may not be there in other modes. It may be present in pressure regulated volume control mode. And why that would occur? Let's see this. So you have pressure which is equal to flow into resistance. So this means to say higher the flow, higher the resistance, and so higher the pressure. This is the first thing you must understand. If the flow is going to be high, higher the resistance, and so higher the pressure. The combination of these two will give us the pressure. So the pressure time scalar that you see here is a combination of flow and a combination of resistance. A drop of the flow or drop of the resistance will drop the pressures. Okay. Now since we have put PRVC mode, what is going to happen is the flow initially will be very high because it has to reach that particular volume as well as the pressure that we have set. That's why PRVC. Now in this, what is happening is initially the flow is high, so you have it rising up, but as it rises up, as the entire flow rises up, the resistance of the airway also rises along with it. That's why the pressure is rising. But then once it reaches that particular value where it says I'm reaching my volume control status, it drops the flow, it drops the resistance. The resistance will come down. That means that it will drop the flow a little bit. When it drops the flow a little bit, the resistance will immediately drop. In fact, the proportion of drop of flow it will be low, but the drop of resistance will be much higher. So what happens over here? The combination of a slight drop in flow with a larger drop in resistance will actually drop the pressure. And so we see this small drop over here which drops over here, but then subsequently it needs to pressurize the circuit to the same amount that we have set on volume control mode. That's why it goes up on the flow, but the resistance effectively is it goes back to what it was. That's why PRVC shows this kind of artifact, and this artifact is called as flow artifact. Okay, it's called as flow artifact. Whatever you do may not change it. If I were to increase this, if I were to increase my I ratio, it may not change anything here. Okay, I reduce the inspiratory. I in fact make it 1:4 also. It will not change anything here. This means to say it's getting higher pressure. Yeah, it's not going to change anything much. In fact, it's still going to remain the way it is. It's still going to remain. It's a flow artifact. By increasing it to 1:5, maybe if I have very high amount of pressures going in, it may reduce it. But then that will lead to a small. It has reduced it, but it will have a small dip at the end, which basically indicates over distension. Okay, it may show over distension per se. Double trigger and other problems will start off the moment we do something like that, because it's just too small for a breath. It's such a small inspiration ratio will make the patient have probable double trigger. That's very important to know. That's why we go back to 1:2. Okay, 1:2, and accept that artifact per se, because it doesn't really harm anything per se. It doesn't harm. It is just a pressurization of the circuit that is changing per se over here. If I were to increase the tidal volume also, the pressurization remains the same. So in fact, it may get amplified. If I do that, it may get amplified. So let's see. 500, it's actually seen there. Okay, it's still seen there. Okay, it's still seen there. Okay, so it doesn't change much. Maybe if I increase to 800, let's see, I make it 600, which is very high. If I make it 600, there's a high possibility we may be able to iron it out to a certain extent, because it is now going to pressurize higher. Okay, it's going to pressurize higher. So it's kind of ironing it out because it is now pressurizing circuit slightly more higher than otherwise. So, but of course, we cannot give 600 as a tidal volume. It's kind of got better because you're pressurizing the circuit more. So the airway pressure, air resistance is flowing same. It is not changing. Resistance is not dropping. Since the resistance is not dropping, why is the resistance not dropping? Because the flow remains the same. Flow is in fact high, remains higher because it has to reach 600 mm in that same inspiration time. And that is why you have this ironed out per se. But however, we cannot give 600 tidal volume since we cannot give 600 tidal volume, we have to go back to a smaller tidal volume, which we normally do for ARDS patients. And that waveform will come back again as a flow artifact. As a flow artifact. Importantly, flow artifact is not going to cause problem because it's an artifact on the ventilator. It is not going to cause problem. Flow artifact has again started appearing now. And as time goes, we will see it more better. Flow artifact. Clear? It has started coming again. Flow artifact. The flow artifact will come back again because of the fact that now the tidal volume is lower. That means the pressurization of the circuit is lesser. So the pressure artifacts will not be seen as much, and that is the reason that you have started seeing this again. Again, you started seeing the same thing. So again, I'll repeat it. Flow artifact is equal, when you go back to your values, pressure is equal to flow into resistance. As the flow, if the flow increases, the resistance will increase. The larger the flow increase, the higher the resistance. This is very high. So lower the flow reduce, much lower the resistance. It will become much lower the resistance. Even a small reduction in the flow will increase the resistance maximum. Combine of this will be the after effect that comes in pressure. Okay. So if this means to say, if I increase the flow in any way, I can reduce the change in the pressure. So that means if I increase the flow by making it 1:2 to 1:6 or 5, the flow is increased. If I increase the flow over here, the pressure artifact will not be changing anywhere. Will not be seen. Okay, the artifact will be on the pressure times scalar. Similarly, if I increase the tidal volume, I will again have increased flow, which will not allow this to be seen per se, because I'm keeping the I ratio constant. So when we come here again, if I increase this tidal volume to say 575, you can see the flow going on. See that? It's almost disappearing. It's almost disappearing. In fact, 600 will make it disappear completely. If I make it 600, it will make it disappear completely. Okay, let's see that. Mostly disappear completely. Let's see. Almost gone. That's why. But however, we can't keep it at 600. So we accept that flow artifact because it is not causing any hemodynamic embarrassment. It is not causing any harm to the patient. It is a flow artifact on the ventilator. Over a period of time, we'll see how this gets better. Once we convert to volume control or pressure control, this will go off. Let's see what happens if we convert to volume control. The flow artifact should ideally go. Okay, so let's see. We go to confirm volume control. It's gone to volume control mode. There's no more flow artifact here. However, we do see that there is no trigger delay also, but there is an air hunger. The reason why the patient is on PRVC is because we want to get off this air hunger, which might cause later problems. And that's why we go to PRVC here, which reduces the air hunger situation over here. Okay? Alright.